The binomial theorem is a tool that we're going to need to use in this proof that we're going for. And it goes like this. This is a very useful tool for taking binomials and raising them to a power. A plus b to the first, to the second, to the third, to the fourth. Okay? Well, a plus b to the first is just obviously a plus b, or 1a plus 1b. Easy. A plus b squared, well, we're going to take a plus b times that thing there. So we'll take what we just had there, and we'll multiply another a plus b times that. And we can FOIL this, and we end up with 1a squared plus 2ab plus 1b squared. Normally we don't put the 1's there, but I want them there for what we're doing. All right? Now, if I want a plus b cubed, well, I'm going to take the squared that I've already done, and I'm going to multiply it by another a plus b. This already is a plus b times a plus b, right? We're going to multiply it by another a plus b. See what's going on there? Well, to do that, we're going to distribute these a's, all right? And when we do that, I'm going to get a times a squared. That's going to be 1a cubed, all right? I'm also going to get an a times a b squared. That's going to be an ab squared, all right? And then I'm going to get a 2a squared b. All right, let me jot those down here. So I'm going to get when I multiply, I'm going to get a 2a squared b. And then I'm going to get I'll go ahead and write that a cubed, backing up there. And then plus, multiply the a times the b, we get 1ab squared. Then we're going to take, and we're going to multiply the b's here. B times a squared, that's going to be a squared b, 1a squared b. And then times that, it's going to give me a 2ab squared. All this is plus, and then plus a 1b cubed. You see how these guys combine there? All right. And so I have 3 of those. I'll have 3 a squared b's and 3 ab squareds. And so our coefficients are 3, 3, and 1. So we are collecting terms, we call it in mathematics, in advanced algebra, as we're doing this here. All right, we're collecting terms. Also, something called combinatorics uses this a lot, the study of combinatorics, a very interesting field of mathematics. Now, we have, all right, I'm going to copy these numbers down, 1, 3, 3, 1. That's what we have here. Let's go one more step. If I want a times b to the fourth, well, let's be a little more creative here. You know, we're going to have an a to the fourth. That's a times a cubed. I'm going to have a b to the fourth. That's going to come from b times b to the third. Then where my a cubed b is going to come from? Well, I'm going to get one of those from here. That's going to be a cubed b. And I'm going to get, where's another a cubed b? Oh, yeah, one there. So I'm going to get a single a cubed b, and I'm going to get 3 a cubed b's when I multiply that. Well, 1 plus 3 is 4. Where are my a squared b squareds? Where's that going to come from? Well, when I multiply this a term here times, let's see, times which one? A squared b squared. That times this guy right here, right? This a times this one, that is going to give me 3a squared b, right? All right, and then I can get another, I'm looking for a squared b squareds. I can multiply this times this one, and see that's going to be a squared b squared. It'll be 3a squared b squared. So when I multiply this one, I get 3. So what just happened there? So we have 3a squared b squareds, and then 3 more a squared b squareds. So adding that 3 and that 3, we get 6. And one more here. Where are we going to get ab cubes? Let me erase this here. So my ab cubes are going to come from this. If I multiply this guy, that's going to be ab cubed. That's 1 ab cubed. And when I multiply these two here, that will also give me 3ab cubed. So if I add these two, we get this number. Now notice that procedure that we just went through. Okay, it was very orderly. Since it was orderly, we're going to be able to use this to continue the pattern. Though that 1 and that 3 gave me 4, that 3 and that 3 gave me 6. This 3 and that 1 gave me 4. And then we're always getting these 1s on the end. Now, what's this one going to be? A plus b to the 5th. I don't want to go through all that again. Well, let's use the same idea. We know that we're going to have 1s on the end. That's going to come from the a times the a times the a times the a there. We know they're going to have b times b times b times b times b. That's going to be 1b to the 5th. And then if we add these two, we get a 5. If we add these two together, we'll have 10 a cubed b squareds. If we add these two coefficients, we'll have another 10. And if we add these two, we end up with 5. All right. Now, this is kind of background knowledge. It's useful to know. But notice these numbers, when we put them together, all these coefficients, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, these can all be found in the Pascal's triangle. Pascal's triangle is made like this. We start with a 1, and then the next row we're going to put a couple 1s, and the next row comes from adding, starting with a 1, and then this in-between number comes from those two being added. Then we continue the pattern, and every number comes from the two numbers above it being added. 2 plus 1 is 3, so on and so forth. And we can continue this. And the reason this is useful is these are the coefficients, all right? So these are the coefficients here of a plus b squared. That's going to be 1a squared, 2ab, 1b squared. And so this is squared, cubed, 4th power, 5th power, 6th power, 7th power. If we wanted to know the a plus b to the 7th, we're going to have this guy, a squared, actually a to the 7th, because we're talking 7, plus, and then it's just going to go down. The exponents on the a goes down and the b goes up. B to the 1st. Then we're going to have a to the 5th, b to the 2nd. Then we're going to have a to the 4th, b cubed. Then we're going to have, moving on over, continue the pattern. You hopefully get the idea. The a's are going down, the b's are going up. A's are going down, b's are going up. And we'll get all of our terms, and so we can know exactly what it is. Now, this is, again, a great background, good to know, especially those of you that are going to continue on in math. Everyone else, just kind of breathe deep and say, wow, that's amazing. And let's see if we can use that.